Hey, thank you for that introduction. I am Kumar Ihsan Mutalyar, and I'm a senior technical lead at Avalara. I hope you enjoyed all the sessions that we had as a part of the Avalara Next event till now. In this session, I'm going to talk about a common developer challenge that we have faced using REST API. Yes, I'm talking about the challenges of underfetching, overfetching, API versioning, and many more. And in this session, we'll talk about a solution that is GraphQL. So let's start with what is GraphQL. So GraphQL is a query language and a runtime for API that was developed by Facebook in the year 2012. Now, why it is called as a query language? So for example, you created an API which provides you a list of users, or it gives you an information of all the users, but you only want the first name and the last name from this endpoint. So GraphQL will give you a language using which you can query this endpoint. You can say that just give me the first name and the last name. Now, how did GraphQL come into existence? Right. In the year 2012, Facebook, they launched their mobile and web applications. But as soon as they launched it, they faced network issues and performance issues. And even the users were not happy with that. And Facebook had to solve this issue, right? So they started an internal project, which was called as GraphQL. Eventually, GraphQL started, it reduced all these problems and everybody was happy. And in the year 2015, GraphQL was launched as an open source. And today, GraphQL is considered as a powerful alternative to the traditional REST API. So what is GraphQL? What are the core concepts of GraphQL? So the first core concept of GraphQL is schema. A schema is what defines what this GraphQL query is capable of. Consider the schema as a blueprint of your API. It tells the user what data he can query for and what are the different type of the data that he is querying for. So a GraphQL schema, it actually looks like a JSON structure, which has the set of fields that you can query. For example, let's consider the Avalara tax domain for this session, correct? So in this tax domain system, we have the different fields like users information, different tax rates, jurisdictions, different invoices that is generated. Now, these are the different fields of that query. Now, for example, the users query will return you a list of users. That is the type that this query will return. So a schema defines both the fields that you can query as well as the data types of these fields. The next is the type system. Yes, GraphQL is built on a strong type system. What I mean by type system is whatever fields that you are going to query is typed, and whatever response you are going to get is also typed. If I say I'm going to get a list of users and the type is a list of users, you will get the list of users. So the type system solves the problem of data inconsistency and also the validations of the data. Next is the resolver function. Now, when I write a set of fields or in the query of your GraphQL schema, there should be some mechanism which will take this query and return me the data back from your data system. And that job is done by the resolver functions. So the resolver functions take the query and they have the logic to where to look for this data, and they return the data in the expected format. So that is a resolver function. Next is the operations. The operations is the main core concept of GraphQL. Mainly, GraphQL offers two types of operations, that is queries and mutations. So queries is to read the data from the system, and mutations are to modify the data. There is one more operation that GraphQL provides, and that is subscriptions. Now, when I read a data, I'm getting a data from the data source. When I modify a data, I'm inserting, updating, or deleting a particular entry from the data system. So you can create subscriptions on these events. And whenever such activities is happening by a query in GraphQL, you will get the notifications. And that is what subscriptions are capable of. Now that we have seen the core concepts, what developer benefits does GraphQL offer? The first benefit that I, as a developer, want to share with all the fellow developers like you is enhanced productivity. With using the traditional REST APIs, you must have faced issues like you get a response from the server, but then you have to process that response to fit into your client, right? But using GraphQL, you don't have to do that. With the capability of GraphQL to fetch only the data that you are looking for, you don't have to do this processing. The second thing is there is no guesswork when you're using GraphQL. In REST APIs, when I get a data, I'm not sure what is the data type that is going to come out from the server. So I'm going to write if-else blocks, or I'm going to validate the data that is coming in. I have to handle error cases and edge scenarios. But in GraphQL, because of the type system, that is not going to happen. Second thing is it is very easy to or modify to bring in new changes into your GraphQL schema. For example, I have set of fields that my API is capable of. Now I want to introduce a new system that is get me the jurisdiction rates. I can easily modify my schema. I don't have to rewrite a new API that as we do in REST APIs. So in REST API, we have a version 1 and version 2, and we simply go on creating new versions. The next benefit is the flexible clients. In case of REST API, there are scenarios where we do multiple iterations on the client based on the response that is coming from the server. But here, the client system is very flexible because it can ask for the data, the exact data that it is looking for. For example, I'm building a dashboard which shows me the user information with the first name, last name, and the email. The client will just ask for that information. So it makes the client system very flexible, and it is very easy to use on any different type of the platforms. Open source community. Yes, GraphQL came in as an open source technology, and today GraphQL's community is growing day by day, and there's a large set of developers who are part of this community. What happens gradually is there are different platforms and different APIs and different third-party entities which are also using GraphQL. So that has done the developer's job easy to use GraphQL. And the last one is improved user experience. Since GraphQL is giving you one schema to access multiple data sources in that, you have a unified schema. Therefore, it reduces the number of network calls that is going in from your application. So the performance has increased. Second, GraphQL provides you a strong caching capability and data storage capability. So you don't have to access hit the same query again and again because the data is cached in the GraphQL system. Third, it increases the load time as well, and thus increasing the performance of your application, and customers are happy with the use of GraphQL in your system. So these are some of the developer benefits. Now let's talk about GraphQL's integration at Avalara. Looking at all the developer benefits and all the benefits that GraphQL offers, we started integrating GraphQL at Avalara in our different REST endpoints. So the first thing that we observed by using the GraphQL in Avalara was scalability. The data doesn't come from one data source. The tax domain system is a complex data system, correct? There is data coming from multiple sources at a time. So GraphQL enables us to fetch this data from different multiple services and build it in a unified single API. And if there is a new requirement, the API is ready to scalable, ready to scale to any extent. The second thing is efficiency. After implementing GraphQL, Avalara experienced a 50% reduction in the network requests and a 60% reduction in the data for user services or the user devices, thus increasing the performance of your application 2 to 3 times that it was before using GraphQL. And the next point is collaboration. Because of the GraphQL's flexible schema, it is easy for teams to share and collaborate with the different data sources that we have. So what we have seen is, since we have a different set of products that we have in Avalara, everybody depends on the tax domain system, correct? So there is not, earlier what we used to do is every team is defining their specific endpoints, but the endpoints do the same job. Now, since we have GraphQL, which provides you a unified schema, all the data comes in from one schema at a time, correct? So that helps you in collaboration very easily. Then I want to talk about this point. I want to highlight this point that is called as building hybrid data sources. Data is the key to any business today, and data doesn't come from one source, correct? It is scattered, it is in different sources, correct? So you guessed it right, that is, I'm talking about building the hybrid data sources. How can I build hybrid data sources using GraphQL? The first way is doing a client-side composition. So what does client-side composition mean in context to GraphQL is the client can gather data from different or multiple sources at a time before showing it to the user. Then is the server-side composition. The server can do this composition at the server level itself, meaning at the server level itself, I query different multiple sources, I get that data, I create that data in the response that in a format that is expected, and I send it to the client. And the third one is schema stitching. Schema stitching is a very important concept of GraphQL. I want to highlight this concept with respect to how partner developers like you can benefit with schema stitching. Now consider you as a partner developer are using different partner endpoints, and Avalara is one of that endpoint. So your giving calls to different endpoints at a time to get a required set of data. But using GraphQL, you can create a unified API, which will have a schema, which has a set of fields that queries to this different partner endpoints. And you will have a equivalent resolver function, which will have the logic to query all the different partner endpoints and return a response. So for example, I have data provider 1, data provider 2, and then I have a Avalara data provider endpoint. So I will write a schema which will have the fields. And this field, for example, I say, get me all the tax invoices. So this tax invoices will have an equivalent resolver function for tax invoice, and it will query all the different providers and return me the response. So schema stitching is a very important feature of GraphQL, which will help partner developers like us. The fourth point is virtual data connectors. So what I mean by virtual data connector is, today the endpoint can be of any type, right? It could be a REST endpoint, it could be a SOAP endpoint, or a GraphQL endpoint, or a simplified API. So you can connect all these different resources in one GraphQL schema, and that is what is meant by virtual data connectors. So let's try to visualize how it will look. So this is the first example where I'm saying, as a partner developer, you can connect to different provider endpoints, and Avalara is one of them, and you can build a hybrid data source, thus reducing the number of network calls. You will have only one API that is doing all this job. So there's only one API call, and it is also easy and to maintain and easy to understand. This is the second approach that I'm talking about, that is the virtual data connectors. I have a REST endpoint, SOAP endpoint, and a GraphQL endpoint, and it builds a hybrid data source. And this is the GraphQL stitching. So as you can see here, there is a schema that is a remote schema, which fetches the products, categories, and such details. And there is a local schema. Using the schema stitching feature of GraphQL, I have come up with one single schema which does all this job. And this is how you can build a hybrid data source using GraphQL. Next important point that you might think about is, what about security and authorization? Security. GraphQL is built on strong typing, right? Strong typing is built into the core of GraphQL, ensuring that the queries are validated at runtime and there is no unexpected data that is injected into the API. The next is authorization middleware. Yes, GraphQL allows you to have different authorization mechanisms, and you can also do it based on fields, or you can have the restrictions to different users, so that you can make sure that no other user is able to access a very sensitive data. Then is customizable error handling. GraphQL provides you with detailed and customizable error handling, making it very easy to handle security related issues, and so that it doesn't impact the user experience. GraphQL ecosystem. Yes, today GraphQL has evolved so much from 2015 to 2023. The number of developers that are contributing to the GraphQL has increased, and therefore the number of tools that are built on GraphQL has increased. You have a lot of tooling options that is present in the GraphQL ecosystem today. Second is the open source culture. Because GraphQL is an open source, there are many developers coming and contributing to it every day, and it is evolving day by day. So GraphQL has brought in new features every year, every month, you can say that. And the third thing is community involvement. Yes, since the community is growing every day, everybody has contributed something to GraphQL, and there are new requirements, and GraphQL has evolved a lot. And there are many companies which are going into using GraphQL today. Now let's look at a demo to see how all these things are happening and how you can benefit using GraphQL. So I have created a demo application here. So this application is built on Node.js. So this is the schema that I was talking about. A schema, it looks like a JSON. So I have considered the Avalara tax domain. So I have created a dummy schema based on that domain itself. That is, I have tax rate, tax category, customers orders, tax return payments, tax invoices. So this is a schema. Now, and this is the main query schema that I was talking about, which gives you all the set of fields that you can query using this GraphQL API. Now, this is the name of the field, and this is the type. So since GraphQL is also built on type system, you have to define the type for every field and every output that is coming out from that query. The second thing is the mutation. You can also modify your data using GraphQL mutations. So these are some of the queries that you can perform to mutate, to insert, update, or delete a data. And then you have the subscription. So as I created an example that is tax payment added. So as soon as I add a new tax payment into the system, I can subscribe to it and I'll get notifications. So now I built this on a simple data, that is I created a JSON structure, and then you have the resolvers. Now every field that we built in the query or every mutation will have an equivalent resolver. So this is the resolver file. So if I go into this, you can see there is a tax rates resolver. So I'm saying that whenever you see tax rates as a part of the query or a field in the query, you just get the data for tax rates, filter the tax rate based on the category ID. So I'm also able to create relationships here. Like a tax category is depend on tax rates. A invoice is depend on tax category. Rate also depends on category. Tax payment depends on customer. So you can create complex relationships as well in GraphQL, define them in schema, and your resolver can combine all this data and send it back to you. Now let's quickly see how this runs. So as soon as I run this application, GraphQL gives you a playground. So this is the playground that you will actually see. And these are the three types of fields that I have defined in my schema. First one is the query, then the mutation, and then the subscription. So as soon as I click query, you will see what are the different fields that are available to query. Now, because of this platform, it is easy to debug and it is easy to see what fields are available. Now, there is a new developer who wants to introduce a new field here. He can go to this platform and see, okay, these are the fields that are already present. You can add a new field here. Now, this field is so easy to understand. So for example, if I say I want to look at the customer data, so it will tell you what is the input that this query will take. That is, it takes an ID and it returns a customer back. So if you click on the arrow here, it will give you all the fields that will come back as a response. Similarly, for the other fields as well. Now, there are multiple fields which are connected to different data objects. For example, in a customer, you can also fetch the orders that a customer has placed. So if I click on the plus icon here, the queries are created here. Now, this is the customer query. It takes the customer ID as an input. I want the first name and last name and the orders related to this customer ID. So I define the customer ID here. And when I hit the play button here, you can see this is how the data is generated here. Now, if you want to see this data as a JSON, you can see I have the customer information. I have just received the first name, the last name, and the orders that customer has placed, the order number, and the products that were ordered by that customer. So as you can see, I'm able to combine different data sources in one GraphQL schema. In REST API, I have to, suppose I'm building this web page in my application, I have to give 3 different API calls, right? I get the customer ID from the user. Using that customer ID, I get the customer name, right? The user doesn't give you the customer ID. You get the first name and the last name. I fetch the customer ID from the customer table. Then I fetch the orders for that customer ID, and I fetch the products for that order, right? So this is the 3 different endpoints. But in GraphQL, you can see I'm doing it in one single endpoint. Similarly, I wrote one more query here, which is called as the tax payments, correct? So if you see in the tax payments, I'm asking for the customer ID, first name and last name, and what is the amount that he paid and what is the date that the payment was made. So it gives you all this data in one single query. The next thing I want to show is the mutation. The mutation is capable of inserting, modifying, or updating or deleting any entry from your database. So here I have considered this example, that is adding a tax payment. So this is the create tax payment mutation field here. If I go to this, it asks for an input. The input is of the type tax payment input, which I have defined here in the schema. So I have to specify the input in that format, which is here in this object. So this input takes customer ID, amount, and date. So I specify that in the variables, and it will return back the fields that you want as soon as it has done the insertion. Now, if I run this one mutation here, let me change something here. I change this number. I change the customer ID to 1, and I change the date to, for example, 10 September 2023, and I run the mutation. So it says the mutation is created for this customer. The data is inserted for this customer, that is John Doe. Now, if I go back here and I run the tax payments query, okay. So you can see now for customer ID John Doe, this was the first entry that I had. Now I inserted a new entry that is for 10th September 2023, and that record is inserted here. This is the amount that I had inserted. So this is how you can also do a mutation. And the mutation can also be done on different data sources at a time, correct? So that is the benefit of GraphQL, right? You can combine different sources or different data sources as one query and reduce the number of network calls and increase the performance of your application. So this is how the demo is. Now, what is the future with GraphQL? GraphQL is so flexible and it has a flexible type system, and its runtime validation makes it easy to create new microservices. Yes, we migrated our microservices, which were REST-based, to GraphQL-based ones, and we have seen a good increase in the performance. The second is development improvements. GraphQL is growing every day, and GraphQL is likely to continue to drive those improvements in the web development, including better standardization and making creating more efficient APIs and broader adoption. As more companies are adopting GraphQL, it is likely to see that GraphQL will have a wider adoption, and it will become a very important part of your web and application development in future. So I came across this a very popular quote which says that people ignore design that ignores people, correct? So if you ignore the design of your system with respect to the performance that it should provide, the customers would start ignoring your application and they will jump onto different application. That is the problem that Facebook was facing, but Facebook didn't have a competitor at that time. But today it's a competitive world, and we have very different applications, a set of applications that provide the same benefit, right? So how you can be at the top is by improving the performance of your application, keeping your customers happy. So don't ignore the design, correct? So that people doesn't ignore your application. So this is a very important quote to make that I wanted to make here. So that's all from my side for this session. If you have any questions, you can put it in the chat. I can answer them later when I see them. And we can also connect if you want to migrate to GraphQL in your backend system in future anytime. Thank you.